All right, today we are going to talk about our other two trig functions, which would be sine and cosine. So our objective will be to use sine and cosine to find missing sides of right triangles. So for our warm-up, name the hypotenuse. What's the hypotenuse of that triangle? XZ. So we can name it with the endpoint since they didn't give it its own little lowercase name. Segment XZ. Name the leg opposite angle X. Again, we've got to use two letters since they didn't give it its own lowercase name. Side YZ is opposite or across from angle X. Name the leg adjacent to angle X. That would be XY. So the one next to it, but not the hypotenuse. If XY has a length of 17 and angle X measures 41 degrees, we are asked to find YZ. So I'll label it with a little X. All right, so we've got everything labeled. Of course, as of right now, we only know one trig function, so the trig function we are going to use is the only one we've talked about so far. Tangent. Tangent of, next to tangent or any trig function always goes an angle. 41 degrees is equal to, good, opposite side we labeled with an X, that's our unknown, over the adjacent side is labeled 17. Now that we have an equation set up, we can cross multiply to solve it. What's the easy cross product? X equals 17 times the tangent of 41. From there, we plug that into our calculator. I would highly recommend putting the 17 times first, and then your tangent of 41. Let's round our answer to the nearest tenth. Anybody agree with 14.8? Anybody disagree with it? Okay. So the measure or length of YZ would be 14.8. Approximately. Questions, concerns, or need more time on our objective or the warm-ups? Okay. Then let's talk about our other two trig functions or trig ratios, sine and cosine. If triangle ABC is a right triangle, then the sine of angle A is equal to the length of the leg opposite angle A. So in this case, that would be side BC, over the length of the hypotenuse, which the hypotenuse is AB. I'll scoot that over a little bit. Over AB. Okay, so sine is opposite leg over the hypotenuse. For cosine, we have the length of the leg adjacent to angle A, which in this case they're already telling us that's AC. So adjacent means it's right next to the angle, but it's not the hypotenuse. Over the length of the hypotenuse, which is, again, side AB. They could have used angle B as their reference angle instead of angle A. And if they'd done that, then the top or the numerator of each of these would have been a different side, but the bottom, the hypotenuse, would have stayed the same. But they only referred to angle A for now, so we'll just leave it there. Questions, concerns? Before we move on to the easy way to remember trig functions. Okay, some of you might Remember this from being on my board either earlier this week or last week. Commonly pronounced SOHCAHTOA. The first letter of each chunk refers to the trig function. So we have sine, cosine, and tangent. Remember, even when we abbreviate them, when we write them, we still pronounce the whole word. Sine, cosine, and tangent. Sine is the opposite side over the hypotenuse. So the O's stand for opposite. All abbreviated OPP. Hypotenuse, HYP. What do you think the A stands for? The adjacent side, which I'll abbreviate ADJ. Adjacent side over hypotenuse for cosine, opposite over adjacent for tangent. Okay, now I usually don't write all of this below, but this way you can know what these all stand for. Or you could write it down below. S stands for sine, C stands for cosine, T stands for tangent, O stands for opposite, A stands for adjacent, and H stands for hypotenuse. Okay, whatever it takes for you to remember your three trig ratios. Questions, concerns? Need more time? Okay, we'll keep it moving. Find the sine of angle S and the sine of angle R. Write each answer as a fraction and as a decimal rounded to 4 places. So, let's start with sine of angle S. So if S is our reference angle, for sine, we want opposite over hypotenuse. We'll be repeating this stuff a lot. Opposite over hypotenuse. What side is opposite angle S? 63, and our hypotenuse is... Okay, I don't believe that fraction will simplify, but they also want it as a decimal to 4 places. So 63 divided by 65 is 9692. Okay, and that's all we need to do for that one. And then we have to switch our reference angle. Now they're wanting us to find the sine of angle R. So the side that is opposite angle R is over the hypotenuse is 65. I don't think that one will reduce. So we need it as a decimal. 0.2461. Questions, concerns? Need more time? Pretty straightforward, I hope. Okay. Find the cosine of angle U and the cosine of angle W. Again, as a fraction and a decimal rounded to 4 places. So they're switching our trig function on us now. We're talking about cosine. Cosine uses which 2 sides of a triangle? Adjacent and hypotenuse. So the cosine of angle U. What side is adjacent to angle U? 18 over the hypotenuse is 30. That one will reduce. What will it become? 9 over 15 will also reduce down to 3 over 5. And as a decimal, 0.6. So it says 4 places, but it doesn't go any further. If you feel strongly about adding zeros at the end, you can. You don't have to put the trailing zeros, though. All right, then they also asked us to switch our angle to W. So the cosine of angle W as a fraction is 24 over 30, reduces to be 4 over 5 as a decimal. Oh, I don't really need approximate in there. 0.8 is exactly 0.8. Again, you can put the zeros at the end or not. Okay, so the purpose of those initially is just so that we get used to identifying opposite, adjacent, hypotenuse, and which trig function uses which sides. Eventually, we will take this a step further and actually be able to calculate the angles themselves, but this would be the first step in doing that. Questions about where we're at right now? Okay, we'll keep it moving. A rope staked 20 feet from the base of a building goes to the roof and forms an angle of 58 degrees with the ground. Now, personally, I would like a little picture of this first. So we know that we've got some building here. Building, sure. We've got a rope staked 20 feet from the base of the building. So 20 feet out from the building is where our rope is staked into the ground. It goes to the roof. So my rope goes from where it's staked up to the roof of my building. It forms an angle of 58 degrees with the ground. So rope to the ground is 58 degrees. Questions about how I set up my picture? Okay. To the nearest tenth of a foot, how long is the rope? So where should I be labeling with a variable? Is it going to be a red line or a black line? The black line, right? The red line represents what? The building, the height of the building. They didn't ask for that. They want to know how long the rope is, which is, in my case, the black line. So that's what I'll label with a variable. No, I do not care what variable you use. Any questions about how we set this picture up? Okay. So then comes the fun part. Based on the angle they gave us and the sides that we have labeled, we have to decide which trig function or trig ratio would be appropriate here. So I'm hearing some votes for cosine, some votes for tangent. Where does the right angle occur here? Okay, it happens at the bottom where my rope starts leaving, or, well, the rope doesn't leave, but my distance from the ground and the building right there, where the building meets the ground, assuming we have good contractors and architects, our building should form a right angle with the ground. So that means X is which side of my triangle? The hypotenuse, which automatically rules out which trig function? Tangent. Tangent does not use the hypotenuse. Are we following my logic here?
Yeah.
Okay, we also need to identify that this 20 is which side of our triangle compared to the angle we have. Adjacent. So we've got adjacent and hypotenuse, which leads us to which trig function? Cosine. So those of you that said cosine initially are picking it up pretty quick. Questions about why we landed on cosine? Okay. Cosine of, next to your trig function should always go what kind of object? An angle. Next to your trig function always goes an angle. This time we know our angle. What is it? 58 degrees. Equals adjacent over hypotenuse. My adjacent side is 20. My hypotenuse is X. questions about setting up our equation. Okay, much like yesterday, in order to solve these, we have to put our trig function over a 1 and cross multiply. The easy cross product here is 20 is equal to x times the cosine of 58 degrees. Again, cosine of 58 degrees represents a number. So what can we do to both sides to get x alone? Is dividing by the cosine of 58 the same as dividing by 58? No. So make sure you're dividing both sides by the cosine of 58. Okay, so cosine of 58 cancels out on both sides. From here, it's got to go in our calculator. What do we get to the nearest tenth of a foot? Okay, so 37.7 feet is about how long our rope is. Again, if you put an equal sign instead of the approximately sign, it's okay. I'm not going to get that picky. I will get picky about your rounding, though. So if you don't have it rounded correctly, you're losing points. Yes. How do we put this in the calculator? What kind of calculator do you have? That one. So for that calculator, you would have to type in 20 divided by 58 cosine, enter. Any other questions? Concerns? Need more time? On we go. A pilot is looking at an airport from her plane. The angle of depression is 29 degrees. If the plane is at an altitude of 10,000 feet, approximately how far is it from the airport? So we got a couple things going on here. We got a little plane up in the sky looking down at an airport. I should probably space that out a little bit better. Okay, so she's looking down at the airport. We'll say, so I have to, that's not perfect. We're going to have to set up a right triangle here. So the angle of depression of her looking down at the airport is 29 degrees. Okay, so that's her looking down, 29 degrees. At an altitude of 10,000 feet. So her altitude is how far up she is. So there's my 10,000 feet. About how far is she from the airport? Well, how far is she from the airport is going to be this distance here. Yes.
How do you know where to put the angle of depression? Like there or the one at the bottom?
I see what you're saying. Practice helps. We'll do a lot of practice on these. So usually an angle of depression is like her looking down. An angle of elevation would be like from the ground looking up. Does that make sense? Okay. All right. So this time, I'm not liking the way this is set up. Let's see what happens. I'm not entirely sure I like how this is going, but we'll see what we get. So in this case, what two sides of our triangle are we working with? Opposite and adjacent, which means we would need which trig function? Tangent. That's why I'm a little surprised that they threw in a tangent here. So let's see if this comes out. If we set up tangent of 29 based on this triangle that I gave you, what would be my ratio? Good. And then to solve this, I'm going to cross multiply. Remember, I always recommend putting your number before your trig function. So 10,000 times tangent of 29. And what do we get? Okay, that seems reasonable to me. Okay, if that's across from the 29-degree angle, that means I didn't draw my picture to scale, but that's fine. So if it said approximately, let's just round it to the nearest foot. So 5,543 feet. Remember, it doesn't really matter what your triangle looks like. Obviously, my side that was labeled with an X looks longer than my altitude, but that just means I didn't draw it to scale, and that's fine. Yes?
So if I'm gonna accidentally put the 29 at the bottom of it, would that matter? Would I have to change the equation?
It would matter because then you would end up with your opposite side being the 10,000. And then, so this fraction would be flipped. And that is going to change how things come out. In most cases. There might be a few where it doesn't end up changing it just because the numbers happen to work out. But in general, yes, if you don't have it set up right, it is going to change things. Other questions? We ready for one more? Okay, we'll practice more of these word problem type so we get the hang of these. Okay, on a homework check tomorrow, I'm not going to give you a word problem. I'll tell you that right now. I'll give you a more straightforward problem. That doesn't mean that a quiz or test won't have word problems, though. All right, let's look at example 5. A dog is looking at a squirrel at the top of a tree. So we assume that the dog is where? On the ground, okay? Dog's on the ground, squirrel's at the top of a tree. The distance between the two animals is 55 feet. The angle of elevation is 64 degrees. How high is the squirrel and how far is the dog from the base of the tree? Okay, so if we set up a triangle. Down here is going to be which animal? The dog. Again, if you set it up differently, that's fine. Up here at the top of what we'll call our tree is the squirrel. Okay. So our right angle, we are assuming it's roughly a right angle between the tree and the ground. We're assuming the tree is growing straight out of the ground. Distance between the animals is 55 feet. Which side of my triangle does that represent? The hypotenuse. The distance between the animals, 55 feet. Angle of elevation. Where is that going to occur, do you think? By the dog. So from the dog up is our angle of elevation, 64 degrees. How high is the squirrel in the tree? So compared to the 64 degrees, how high the squirrel is which side of our triangle? It's not the hypotenuse. Opposite side. Okay, so we'll give that an X. How far is the dog from the base of the tree? That's another unknown. So we'll give that a different variable like Y. So let's just do one at a time. We'll start with the X. We already said that side is opposite, and the side that we know is the hypotenuse. So if we're talking about opposite and hypotenuse, which trig function do we want? Sine. So the sine of, what should go right next to sine? The angle, 64 degrees, is equal to X over 55. Opposite over hypotenuse. Put it over 1, we cross multiply, x is equal to 55 times the sine of 64. We'll go ahead and round to the nearest tenth on this one since they didn't tell us. What do we get?
49.4.
49.4. My units are feet. So the squirrel is 49.4 feet high in the tree. Okay, we still want to know how far the dog is from the base of the tree. Now, when you do these problems, and we'll talk about this more later probably, technically there are a couple different ways now that you could figure out the last side. What's one way that we've already learned before we talked about trig functions that you could find the missing side of a right triangle? The Pythagorean theorem. Now, I don't recommend that when you have to round one of your sides. Okay, because then you're going to end up rounding again, and your answer might end up just a little bit off from what it's supposed to be. Okay, so I wouldn't recommend using a rounded number in Pythagorean theorem. So instead, I would recommend using another trig function. So this time, the side that I labeled y is which side of my triangle compared to my 64-degree angle. Adjacent, and 55 is still the hypotenuse. Adjacent and hypotenuse uses which trig function? Cosine. So the cosine of, what goes right next to cosine? 64. It's always an angle. Good. Adjacent over hypotenuse. So y over 55. Now this looks a lot like our last setup. We just switched our trig function, which by and large means our answer will come out different. So changing the trig function does change the number significantly in most cases. There are some special cases where it won't. This is not one of them. So let's get y to the nearest tenth. 24.1. So the dog is approximately 24.1 feet away from the tree. Questions, concerns about our notes today? Okay, your homework is in your book, should be on your assignment guide.